Hello and welcome back to the channel. Apologies for the delay since the last video. I switched out my phone and that caused some technical issues with audio. I have a new mic now, so we should be good to go. That's provided by a new friend of mine, so thank you for that. Shout out to him. So a quick recap from the last video. In the last video we set up an AWS account and we also started updating some security with it, creating some roles and some groups, some users. We create a developer role to code with, create a new repository. We were able to pull down and clone that repository into IntelliJ. So we should be good to go now to start doing a little bit of coding and commit it to that repo. So for today, our main goals is to get a starter web application. High level, this is just going to be a REST endpoint I can call to do some integration tests. For now, it's just going to return back a string saying that we were able to invoke our endpoint successfully. As we build out this API to call Robinhood and other providers and brokerages, it will be used to have me be able to call that endpoint, give it the credentials for my login to Robinhood, and it will run through a set of core functionality calls and then report back which ones pass and which ones fail. That would be a good, easy way to kind of test my application as we make changes, make improvements, and develop more and more features to it. So this is going to be setting the groundwork for later use. So this repository, this application is going to be with Spring Boot. Spring is an easy way to get started quickly. Does a lot of our dependency management for us with a lot of the Spring framework components. We will use the Spring Boot starter parent, I believe, as a parent dependency, Spring Boot starter web, and I believe Spring Boot starter. So after we add those dependencies, we'll create the framework for our Spring Boot application, which is super simple. So we'll walk through that. We'll create a simple REST controller, a endpoint, just to return back a string saying you successfully invoked the endpoint. We'll try to build that, run it locally, and we'll use Postman to submit a request to it. Make sure we get that response back like we expect, and assuming all goes well, we'll commit those changes to a repository, and that will be our endpoint that we can start testing with. So let us get into it. So again, I'm using IntelliJ. It's an IDE that I've been working with for a while now and I enjoy, but if you are used to Eclipse or VS Code or any other IDE, yeah, that's fine. It doesn't really matter. The important part is the code. So whatever IDE you're most familiar with, go with that. But for me, I'm going to be using IntelliJ. I'm also using Maven, so I touched on that a little bit before. Maven is used for dependency management, to build our artifacts, to run our unit tests, and if we have integration tests, we'll run those. So it's just a XML-based plugin or build tool, dependency management tool. When we created our project IntelliJ, we chose one of the archetypes to generate some framework code for us. So that's why we have some of these classes already set up for us. And also included a pom.xml. Pom is what Maven uses to define your project and your builds and dependencies, all that fun stuff. So all that was generated for us. So we should be able to use this and get right into it. So the two sections in here that we're going to look at is the dependencies block as well as adding a parent block. So one of the things that Maven does is you can kind of daisy chain different POM files together. So if you depend on a parent that has other dependencies, you can define that parent, and it'll then go to that POM, pull that down, and get all those dependencies as well. So you can use that to our advantage. So, all that said, we will go to Google, and we need Spring Boot Starter Parents Maven. And one of the first links is to the Maven repository. Let's go with the latest build. And it has the dependency that we need. So we have a couple options. We can paste that down here to our dependencies section like so. Then as you see in the bottom, it's going to resolve those dependencies. So it's going out to Maven's central repository to look for this artifact from this group with this version, pull it down to our local machine to run with. Now it's changed from red to white, so it's able to find that. The other way to do this is to add in a parent block. So similar deal, in the parent block you're specifying that this POM depends on and will roll up to another POM. So in this case, Spring Boot Starter Parent. And again, we just give it the version, the group, and artifact ID, and it goes out to Maven repository to find that dependency. So that is that one down. The next dependency is Spring Boot Starter. Again, we'll go to the latest artifact that in our dependency and wait till that downloads. And this is just a like a starter set of dependencies that allow us to use Spring Boot. So all the classes that we'll need, all the annotations that we'll need, all those kinds of things will come from this Spring Boot starter in order to use Spring Boot. Since we are making a REST server, REST endpoints, so this is also going to be a web framework to a degree, we need another dependency. Let me remember what it is. Spring Boot Starter Web. Copy this dependency. Also put this in our POM. Go ahead and tidy up the indenting on here a little bit. And this dependency will give us the annotations for our REST controller for our annotations to specify a GET request, POST request, our request body, request type, all those kinds of annotations and classes will be pulled down with this Spring Boot Starter Web dependency. So I believe that is all of the dependencies that we need to get started. So looking back at our tasks, we have step 1 done. So now we need to make our default application a Spring Boot application. That is very, very simple to do. So we'll get rid of some of this default code. Do the at Spring Boot application. And now this should run as a Spring Boot application. This does quite a few things behind the scenes, and we can dive into it a little bit. This would be pretty advanced if you're just starting out, but just a couple high level things that this does for us is allows us to run it as a Spring Boot application, so it has a built-in web server as part of that. It has an auto configuration as part of it, which is this annotation that it includes enable auto configuration. So if we have different components and services for different classes that we're going to auto wire or inject into different classes that we need it for, the auto configuration will scan through all of your classes and all of your packages to find any Spring Boot beans, classes, components, and any other Spring related annotations, and configure all those behind the scenes for us. It'll wire everything up for us. It'll put them all in our Spring context for us when it starts up. So it's going to do a lot of things behind the scenes that we don't need to worry about for now. So that is, I believe, step 2 complete. So moving right along to step 3, creating a REST controller. So first we will make a new package, and we will say this is web for now. And then make a new class inside of it, and we will say test controller. So this class, again, this endpoint's purpose is just to be invoked to make sure our service is alive and healthy, and provide endpoints to run some simple core functionality tests. That way I can, when it's out in AWS, be able to invoke it locally from any browser and have return a payload back to let me know that the application is alive and healthy and running as expected. So the next annotation we need is at REST controller. This will signal to our Spring Boot application that this class has REST server stuff in it, which is useful. So I believe that is all for step 3. Step 4, creating a test endpoint. So this will be what will this be? So usually if you're just retrieving data, it's a GET request, which doesn't really have a body per se, so there's no real payload to give to it. I believe I'm still going to use a GET request, so it's kind of just getting data back. It's going to run some tests for me. I'm not going to persist or save any data, but we'll probably still send a payload to it, which is the credentials I need to log in to Robinhood to run the tests. So real quickly, we should be able to do Java REST one example to get a simple one. And this should be fine. And this is a bit overkill for what we're doing, so we'll make lots of modifications to this guy. So we'll do, go away. So go away. Let's do string test services, and I'm going to take in anything for now. Actually, we'll do this a little bit nicer. So string result, we'll initialize it to So I'm just kind of putting in a little bit of what I'll explain through all I'm doing here in a moment. Make it a little bit easier while I think through this. So I'm going to create a string, just return back the results of these tests. You can return back JSON or XML or all kinds of different formats, but for this simple endpoint, for now, this is going to be a string. This is going to be set the framework in. So right now we have no endpoint or no test that we're going to run. So it's going to be no passing, no failing. But as we add in different calls to Robinhood, we can add that to this list. So for instance, we'll have a call to Robinhood to log in and get a secure token back. So this class, when you invoke it from the REST call, we'll go ahead and do that call to Robinhood. And if we get a token back, then we'll increment our pass count. If we are not able to, we'll increment our failed count, and we'll say which test cases pass and which test cases fail. So that way it will be a list of all of our passing and failing test cases. Integration test. So int pass equals 0 and fail equals 0. Initialize both of those. So every time it will say successfully invoked endpoint running tests, and here we will in the future add in our calls to different test functionality. And add to result string and counters. So we'll just add to this list every time we make a new endpoint call. And then after running all of our tests, it will print out what our overall passing and failing count is. So that seems okay to me. So public, so it's going to be called from anywhere. It's going to turn back a string, test services. This request mapping annotation is specifying the URI of our endpoint. So we can name this whatever after our domain, like www.autotrader.com/ everything after the slash should be our request mapping. That way, Spring Boot and Spring Web will know how to map requests to the right method. So we'll name it Test Services. I believe all that looks pretty decent. Looks good to me. So that should be number 4. It's number 5, start application. Alright, so let's start seeing how we've done so far. So Maven has a lot of built-in commands. So we haven't specified any goals, which is fine. That's expected for Maven right now. So Maven, you specify goals, what you want Maven to do. So it has clean, install, package, all these types of different targets to invoke. So right now we will try to do Maven clean install. So the clean target will wipe out any previous built artifacts to have a clean state. And then install goes through a series of goals by itself. So it'll compile your code, it will run any unit tests, integration tests, and it will put your artifact in your local repository. So it does quite a few things behind the scenes. So we can look through everything it did. So it cleaned everything out. We didn't have anything built, so that didn't really do anything. Then it went through and built the artifact and compiled the code for us. It's downloaded any plugins and things it needs to run. It ran test cases. Our framework included a just simple dummy test case to get you started. So it ran that test case and reported back that we ran one total case and that passed. No failures, no errors, and we didn't skip any test cases. And then finally, since we did the install command or install goal for Maven, it put that in our local repository, which is fine. So also, since we built artifact, there's a new target directory. Inside here is our jar. So this is the built artifact from Maven. So that step should be done. So we have a built artifact. Now we need to start the application. So Maven, I believe this is the right command, Spring Boot run. We will find out. So this one also download any dependencies, recompile your code, make sure you have everything compiled, and it should also start a Spring Boot application, which it did not. So let's figure out why not. Let's first look up to make sure my command is right. That looks right. Alright, so I'm missing something. Let's go back to a simple example and figure out what part I missed. So we have a controller. This line. Forgot that line. Don't seem right. Should be our own class. Alright, so I forgot this line. We had the right annotation to have it scan and look for everything, but your main also has to have this to actually run your application. So let's go ahead and rerun this command and see if we get our application to start. So it's starting our application. It started a Tomcat server. It successfully booted up. So we should be running. So it's waiting for requests to come in. So now we go to Postman. So Postman is a really awesome tool. You can configure it to send requests to endpoints. You can specify what kind of data to send to it, what kind of request it will be, if it's get, post, put, any of these. You can give it different data, different ways. You can give it payloads, and it'll send the request, and you can see the response coming back. So it does lots of awesome things. We probably won't use all the features in here because there's quite a few. But we will get started with adding collection. So collections are just a way to organize all of your requests, so you can keep track of the requests you make. So our collection name, we'll say this is Auto Trader. We don't need any description or anything at the moment, so we create that. Has no requests, so we will create a request. Localhost port 8080, and we get that from this. So it's running on 8080 by default. There's ways to override that if we need to, but I don't really have any reason to. There's nothing else running on that port. And then our endpoint we named is test services. Send request. And we get our payload coming back. Successfully invoked endpoint. And that is what we expected. So good news. So we're able to invoke our service locally. Since we know this payload works, I'm going to save it as test services basic, sure. And we will save it in the AutoTrader collection. And we should be good to go. So now we can invoke this as many times as we want. And it works. Control C to go ahead and kill our server. Just to do a quick recap. We were able to start application, we tested application locally with Postman, and now we just need to commit our changes and call it a night. So get status will show us everything that we've added and modified. So we've modified our POM, our main application, created a new package and associated classes with that. And also has this target directory, and we don't want that because we don't want to commit the target. So there's a git ignore in here as well. And this git ignore will exclude things that match these patterns from being considered for git command. So you don't need to worry about adding them and committing them and pushing them, that kind of thing. So we will do target and any subdirectories and any file under that. So git status, we no longer see the target directory, but we've modified the git ignore, so that's added. So that looks good. Git add will stage all of our changes. If you do a dot at the top of the directory, it'll stage any new classes, new packages, new files, and any modified files in any directories below it. You can alternatively add specific files or specific folders, things like that. But usually I just do a git add dot to say I want to commit everything I've done. Now if we look at the status, it's turned green, indicating that they're added to the staging area and ready to be committed. There's no outstanding things to add. So git commit is next command to run. The -m flag allows us to have a message with this commit. That way it'd be easy to see what this commit was for. So we'll say set up initial Spring Boot application. Also added test services endpoint. So that has committed it to our local Git repository. This next command, we want to push our local out to AWS, since that's where our remote repository lives. So git push. It wrote all of our objects. It does not show any errors or any issues. It pushed it to AWS, our remote repository, and CodeCommit. So that is all that we had. Go back to our goals. We completed step 7. So that's it. Just to recap everything we did tonight, we got started on our dependencies. We converted our dummy little application to a Spring Boot application. We added a REST controller, a sample endpoint. We were able to start it locally, and we were able to test the endpoint with Postman, and we committed all of our changes to CodeCommit. So that is all the things we need to do today. So a little bit more on the upcoming videos. I've been thinking through which route to take. I believe what I've decided is to go through and build out a code pipeline in AWS. So it'd be a little bit of DevOps work. So AWS, I believe I mentioned it a couple videos ago, has different services to create a pipeline where you can detect changes to a branch, build an artifact, save that to an S3 bucket, and deploy that artifact to an instance, and the whole 9 yards. So I believe that's the next series of videos, is breaking that down to each step and to build out that pipeline. So the end goal is going to be a very stable, solid framework for us to build our application on. So that whenever we do make a change, add in new endpoint, add in new functionality, as soon as we commit it to the master branch, it'll kick off that pipeline, it'll build an artifact, it'll deploy it to our remote instance, EC2 instance, and we can invoke that with Postman instead of localhost, this will be the IP address where our instance lives, and we'll be able to see all of our changes pretty much in real time. So that way we can immediately get results on if we are making progress in our Build With Me series. So I think that's the direction that we will take. That'll probably be 3 videos, give or take. So a video on the pipeline and setting up the CodeCommit trigger, video on the code build, so building the artifact and storing it, then a video on the deployment aspect of it to deploy it to an EC2 instance. Might be 4 videos to set up some of the backend systems to support all of that, but hopefully y'all will enjoy that and get some useful information from it. But with that, that is all I had for y'all tonight. If you learned something, that's great. Let me know in the comments below. If you haven't already, go ahead and subscribe as I work through more videos so you can be notified. Like and comment below anything that I can help out with if you run into any issues or have any questions. And with that, that is all. Have a good night. Bye.